Hi, again. My name is Mantas. I work for Uber. And today, I will scratch the surface about what tools on observability stack at Uber we built, why we built them, and a bit how we use them. First of all, a bit about me. During my career, I worked in very different teams. I started in operational teams, then moved to development teams, and something like DevOps teams, SRE teams, something in between that. And in all those teams, when I was working, I fell in love with metrics. And what's so special about metrics and what they are? So metrics are measurements, right? In the simplest form, it's like metric path or metric name. That is what we're measuring. Timestamp, it's when we measure is done, and the value, what we get from measuring. And the measuring things is very masculine, right? Like we like measuring things. We like comparing with our colleagues. We like to brag about this. For example, we can measure the amount of containers we have with our environment and say, wow, now now I have 3,000 while my colleague has 2,500 running, and I can enjoy that. Other thing, when you start measuring things, you can visualize them. You can start drawing some graphs, put them in the wall, put them on the screens, put screens on the walls, or you can put them actually in the art museum, because metrics could be even an art. This is an actual picture I taken in a museum in New York. This metrics is from certain topics from Wikipedia. And I can assure you that when you start measuring something you haven't measured before, you will be surprised by one or another way. Do you know this guy? Right? Like everyone just does this. Oh. So this is Lance Armstrong, right? Like well-known bicycle rider, won multiple times Tour de France. Have you heard about Lance Armstrong bug? Anyone? No. So Lance Armstrong bug is when your application passes all the tests, but the evidence shows that it doesn't perform as it should. Right? So what's evidence in this part? Evidence could be metrics. In most cases, could be metrics. And I will tell you one story from my experience. Just in the company before Uber, it was my first weeks in the company, and the business guy comes to me and says, our website, yes, he says, our website is slow. And I say, well, okay, what's your website? I figure out this website is served from an application. I just load it, it's loading. It's kind of slow, but still loading. And I ask him, do you have any measures? How it was yesterday? What's changed? I ask my colleagues. Apparently, there's no measures. We're not collecting any metrics. As it was the end of the day, I went to the hotel, scrapped some script, and start measuring the time it needs to load this web page. And apparently it was 40 seconds. And this is was a wow moment for me. 40 seconds, and we're still in business? We're still using that? Someone? So I went to my colleagues. Next day, we actually made some more measurements, some more metrics. We start collecting different metrics on parts of on that application, and we pretty easily found in hour or two what actually takes us 38 seconds in that application. So we went to the developer who actually wrote that part and said, what's that? And he said, oh yeah, that's sure. I always knew this. I just don't fix this. So we asked him to fix it. He fixed this in 1 hour. And when you put the metric graph, and you have 40 seconds, and in 3 or 4 hours you have less than 2 seconds, that's insane. You can grab this graph and go to your manager and ask for a pay rise or immediately, right? You've done your job for a month. So this is my story about metrics. Now it's a bit about Uber. Uber is still a pretty young company. It's 7 years old right now. We operate in 6 continents, 72 countries, and more than 400 cities around the globe. We operate in Tallinn as well. Who is user of Uber? Oh, it could be more. Could be more. Anyone try to drive Uber? No one. apparently it's not cool for IT guys to drive it. So we have more than 1,000 engineers, and we do like more than 5 million trips each day around the world. We have engineering office in Vilnius, where I'm from, and I work in that office. We have 4 teams there. We have observability, which actually doing with host level metrics and alerting. We have databases working with MySQL, Postgres, and other stuff. Foundations, where I'm from now, we're doing configuration management. For Uber, we're doing some kernel patches. And development experience. Those guys are writing the tools other developers are using, as can be seen from name. Now we have something like more than 20, but it's more like it's like 30 engineers in our office, and we're still expanding. Their office was founded like 3 years ago. Myself working at Uber for 2 years now. Okay, so Uber. One thing about Uber, again, it's the super growth. At the time I joined, it was something like 300 engineers. As you saw, now we have more than 1,000, 2 years past. The same happened with our services. Number of services, we're using like microservices, number of services just grew tremendously. And now it's way beyond 1,000 and still growing. Why it's important? It's important for metrics because this amount of services makes huge amount of metrics, huge amount of data we need to collect. At Uber, how metrics looks like, we're handling actually like 500 million different time series with different metrics. We are writing 3 million and then querying for 1K. And we needed to deal with this enormous growth at the time. And they asked me like, why so many metrics? Why are you collecting so much? And this is because Uber is not like one business. It's like many more businesses around the world. Like we need to measure how Uber Pop, I think that's called in Tallinn, right? Like how Uber Pop it's doing in Tallinn, and how Uber Eats it's doing in New York. It's very different types of metrics, very different data we collect and measure. And this T1 service means that at Uber metrics considered the most, like, between those most important services in our infrastructure. What that means, like, I don't know if you're saying what happens in the plane. When planes, it's flying, it collects a lot of data about how it's going on and the speed and high. I don't know if you've seen, like, or you can imagine what happens in the plane cockpit if they lose all those metrics. What could happen there? It's like, I bet there will be some chaos there. Something like this happens in Uber if we lose our metrics. We can say like, are we flying now? Are we going down? Are we going up? What's happening? Is this application running? Or do we have any outage? So this is super important for us. Exactly as a plane, Uber won't go down at the minute or at the second we lose all the metrics. We still will be running for some time, but it's just a matter of time when we will go down without metrics. So to keep metrics running, to keep that system working, it's super important for us. Next, just roll back a bit, like go back like a couple of years, like a few years ago. Uber wasn't so big, and it's like 2013, which is like 3 years ago. All Uber metrics were collected. We were using Graphite as a system. It's pretty standard setup. And this is not that I draw one server. Actually, 3 years ago, all Uber metrics was going to one server, was handling by one server. We had Whisper database, we have Carbon cache here, like everything simple. It worked at that time. When I joined Uber and took over Graphite installation, it was a bit more complex then. We had some sharded stuff, we had states D in the middle, we had already like Ubermon, which is like metrics collection, local metrics collection agent on the server. If you're familiar with the Diamond, which is open sourced, it's pretty much does the same functionality for us. We had some stats relay services on on each server just to buffer metrics before sending them through network, because we will start killing our network. So the setup was a bit more complex, and we already had problems with it. I don't know if anyone tried to reshard Graphite, but it's not simple, easy, fast task. And in our case, with this growth was literally impossible. We tried to reshard our Graphite stuff, never ever did it successfully, because like in the middle of the process, we understood that even if we finish, we will fail to serve our customers, because we won't have enough power to handle everything. So we added more servers in the middle, again, the same process, even though even we tried to over-provision like really hardly, we didn't succeed. We had problems with Graphite services running on one core, and everything was kind of on fire. At the time, we said, like, okay, we need like to build something else. This solution apparently doesn't work. And of course, we looked what's available on the market. We looked into, at the time, actually, Netflix open sourced a part of the metric solution, and as we work for such company as Uber, you can allow yourself, like, invite a couple of Netflix engineers to your office and have chat with them, have presentation from them, like, really, what's this Netflix metric system is about? After having that, we understood that that's not the way we could go. Sorry. So we looked into other solutions. InfluxDB wasn't ready at that time. They didn't have any scaling history, and they had no idea about how to scale at that time. So we looked into BlueFlat. It was a solution from Rackspace, and a couple engineers worked on in Rackspace for this solution. They already moved to Uber, so we had some knowledge inside. So we contacted them and tried to implement BlueFlat. The thing is, like, in the first iterations, it just started it wasn't performing. And I called the guy and says, like, okay, on your documentation it says there should be performing. We did everything what it said, but it's not. And he says, like, how many metrics are you collecting? And I said, like, well, I don't know. We just like grabbed some piece of production and probably some 50 millions. And he says, like, 50 millions. This system was like designed for 1 million. We're handling 1 million in Rackspace. So apparently it didn't work. And at that time, we took design of BlueFlat and started developing our own metric system. We call it M3. We're really sophisticated with the names. So the good thing, what we did, it's, as I said, like, we took production traffic. It was like production metric flow. And the second or third day, we took that traffic and diverted to our test solution. And we could see how it works. We could iterate. And this approach, what we're trying to use developing our next generation of tools as well. Like, as soon as possible, just get production traffic and see how your solution works on that. We have Sachant, which actually was like guarding production from, like, if we messing up anything here, it was guarding production not to put back pressure onto production. So we just ingester, we use Cassandra as a database, ingester just inserting metrics into Cassandra, index servers at the time just like indexing and Elasticsearch. Nothing super fancy there. And we iterate on that. We iterate, we wrote our own new iteration of metrics collection agent, which we're running on all the systems now. We're still using StatsD for some parts of metrics. One thing we actually added is this aggregator. And when you send the metrics to Cassandra, at some point you want to aggregate them to bigger buckets, right? Like the same as Graphite does, same other system do. So in the first version, we actually read from Cassandra metrics, put them in an aggregator, aggregate it in the bigger buckets, write again into Cassandra. And Cassandra is really great for writes and really good for reads, but it's not good when you do lots of reads and writes at the same time. So now we are running aggregator who actually receives the same metric what ingester does. It aggregates them in memory and do writes in Cassandra. So we escape like big portion of our reads from database. Still indexing in Elasticsearch. I'll show how it's, yeah. So a bit more about Cassandra. Cassandra is like, if you look in the Wikipedia, Cassandra is the figure of epic tradition and tragedy. So we lived our moments, like really painful moments of scaling Cassandra, growing Cassandra, learning Cassandra. So if you take this on production, just put some bit of cautious. It actually could handle like really great amount of writes. It supports data tier compaction strategy, which makes like how Cassandra handles data on the disk, and which makes perfect for metrics. And additionally, it supports like native TTL, which can like all the metrics could be discarded automatically. We don't care even about deleting them ourselves. So it was kind of good working database for us. What we figure out as well, we figure out that the data we collect, it has like different retention policies, different types of data we're collecting. Initially, we had like one huge Cassandra cluster. Then we split it to handle those different cases. That it made managing clusters a lot easier. And even though if we could have like problems with one Cassandra cluster, we could divert our metrics dynamically to another Cassandra cluster, and then when selecting, combine them. Currently, as we're still not super happy about Cassandra, currently the team in New York, they're developing their own metrics database for handling metrics. It's called M3DB. It's developed as open source project. You can check it out. For querying data, it was really nice. It was interesting story when we actually migrated. We said, okay, so now we need like copy metrics from Graphite to the Cassandra. And whatever we did, the best attempt was like it would take us up to 3 months to copy metrics from Graphite to Cassandra. So we wrote our own query service who actually were able to query from Grafana and Cassandra at the same time based on what time range you actually ask. And now they could actually, we're using this functionality for querying different Cassandra clusters. So if you say you want this metric for this time range, we say, okay, this cluster should have this data. The whole solution up until this place, the whole solution up until this place, it's totally like 99, I guess 99.5. Backwards compatible with Graphite. So our users were not affected at all. They didn't care like, are we using Graphite, M3 or something? They haven't seen this transition. It's been some painful outages we had, but in a big picture, they didn't care about this. Everything backwards compatible. The tools they wrote, they could be used on the solution as well. We're still using Grafana for making dashboards, making graphs. I could bet actually if I did this talk like after a year, we will migrate from Grafana as well. There's so many use cases we can't do with Grafana, but currently it's Grafana. The thing is, when you open the metric system, make it reliable, make it fast. The engineers using it as a free resource, right? We have teams who are responsible for, like, all teams at Uber are responsible for metrics they are sending, for being on call of that, for making alerts out of those metrics. They're responsible for that. So they're sending pretty much lots of metrics, but they not always care about what they're sending. They say, like, I just like send to this endpoint, and what I care, this metric shows up in Grafana at some point. But with this approach, as treating metrics as free resource, there's lots of abuse, like the engineers abusing the system. What I saw, we start sending like, this is actual metric, like check UID or UID, apparently some kind of error, or like IP address in a metric, or telephone numbers, or some other numbers in there, which makes metric like, each data value unique, or it's like not usable, not curable. So what solution for that? What we saw this trend, and then we needed to fix. And when you have a lot, like in smaller company, you just go to developers and say like, okay, just don't do this, just don't do that. But in bigger company like this, it's literally not possible to go to every team. You need to enforce things. You need to show things. So solution for this was more metrics. Metrics about metrics, right? We start collecting who is sending metrics, what metrics they're sending, what's the use case of them, do they query them, do they use them in alerts, do they use them in dashboards? And then exposing this information, you can approach managers, you can approach those teams, you can discuss with them, you can have proper discussion on this, and you can enforce things. Like if you're not using your metrics, you won't be able to send them, something like this. Other thing, it's like, I don't know how many of you are familiar with like Graphite way of querying metrics. This is kind of default Graphite query. So if you go like further and further, it's like stacks like this. It's not very intuitive, and it could get really, really messy on the screen you're writing. So we said we need like new query system for the metrics. And tag-based metrics seemed like appropriate solution for this. From this point, it's not backwards compatible with Graphite. So we need to be sending metrics in special crafted way with tags that we're able to query them. We can actually even predefine some variables, then we can fetch, like, let's say name, metric name, some color like cyan, and we can apply functions pretty much like in Linux Word with the pipes. Let's say pipe aggregate, pipe this, pipe this. So it's a lot more intuitive for the engineers to use, a lot more, it makes more sense out of the metrics and makes them more searchable. Like if you're not the guy who made the metric, it's really difficult sometimes to find out what I need to look for. So with this approach, it's easier. And I will try to show you a bit of example. Let me check. Right, can you see this? Right. So this is Grafana, right? This is Grafana. This is normal way how we query metrics. And if I try to run the same query, I need to actually repeat everything like it's here. So if you close my eyes, I can't even do that. Engineers need to understand what those, for example, what, come on, just work. What those stats means, what HDC1 means, because some fields actually, when they send metrics, they don't care about all fields. We're pre-populating some fields based on data center, based on type of the metric. So they need to be aware of all of this. Then they need to write some mobile analytics, right? Like if you close my eyes, like I probably won't even like figure out how to repeat this. And it's orders matters, everything it matters. You don't even know what those fields are. For example, if global, what means global? What's that field means? You don't even know, right? You can select some values, and based on that, you can make some guess, but that's it. So this is like M3QL way. And this is a bit different in Grafana, if you ever saw this. This is a bit, we patched up Grafana a bit. If you choose the source, M3QL, it actually gives you interface like this. And now metric makes a lot more sense, because like if I would like to write a metric, now I can say like, okay, now my service, what I need, my service would be mobile analytics, right? And then I'm just limiting numbers and numbers. It's like I'm making sense of the metrics. It's a lot easier to look for. And now it's like I'm kind of limit, like I can write like city. And wow, city I can sit. And global means like city. So it starts to make sense. And I could continue and continue like this. And probably if I a bit aware of the service, I would make sense of all the fields and I could repeat pretty easily. And the functions, so if we saw like this, it says like we're limiting query for 10,000 different data points currently, not to kill our system from Grafana. But if I apply, I can apply functions like this as well. Like I don't want to like in one line, but I can like, okay, this is transform null. I can transform null to 0. I can add some other functions like alias and blah, blah, and I can continue and continue and continue, right? In order to do this, we wrote all the Graphite-related functions with Go, and I haven't mentioned all the M3 is written in Go as well. You see this, right? Okay, so when you have metrics, when you have able to query them, you need to make alerts out of them, because like even though those dashboards are really nice, and myself I could stare at them like during day and night, especially to nice dashboards, but not many people as me, and they want like actionable alerts out of metrics. So we had the system which was like you crafted some kind of this script. The script was gathered by another script, converted to actual alert, nudges alert, put on the system. And it was really flexible because you could actually write a lot of stuff here. And when you make too flexible for engineers, they're trying to abuse this, the same as with metrics. So we wrote another tool, not just to limit engineers or anything, but to make it more understandable, more easy to create alerts. Yeah, I was forced to shade this query, but you actually write the query, you see the data here, you see your thresholds, you can set thresholds in the UI, and you could see it in history when your thresholds would work, when they wouldn't. You can actually tune them by the data. Everything is in UI, and it's more and more accessible now to all engineers. So metrics nice. Having alerts for them is nice, but if you ever try to set an alert, it's not easy. It requires some investigation, what metrics actually look like in the history. Requires some understanding what actually happens. Requires some maintenance. Bless you. Requires some maintenance. Even if you like set the thresholds, it requires constant maintenance of those because data changes, and then you can alert it when actually action is not needed, right? So those manual alerts are not flexible at all. And even when you have the cases like this, when the max lower threshold exceeds the minimum upper threshold, where you set the metrics, it's not so easy to figure out. And in cases like this, when the actually drops, and if you look in the history, if you set the metrics here, like threshold here, it won't work, right? So we built another system called F3, another very advanced name for this. So F3 actually goes into history for metric. Let's say if now it's like Thursday, 5 p.m. It goes for the 4 or 5 Thursdays and 5 p.m. in the history, looked how metrics look like in that period, applying some clever algorithm and figure out how that metric should look like in next 30 minutes. So basically we do predicting. We're predicting how this metric should look like in next 30 minutes. And instead, of writing, introducing another UI tool, another system to engineers to deal with, we integrated this with Grafana. So this is metric you're looking for. You're applying this anomaly detection system, this F3 we built. Anomaly detection system calculates your metrics, how your metrics should look like for the next 30 minutes. It pushes data back to the metric system, and you are able to draw your thresholds on the line with your metric. So the green line is your metric, and blue line is upper threshold. Yellow line is like lower threshold. Those are dynamic, all the time calculated for 30 minutes. So engineers could see this, it's available for them, and the tools they already used to. So how you make alerting out of this? How you now alert? Because if green light crosses any threshold, you need to be alerted. So we wrote another function called anomalies. You just wrap up your function wrap up your query into this anomalies function, and it actually gives a score based on where your metrics are compared to thresholds, from 1 to 10. Everything above 4 worth alerting. So it's now very easy to create alerts as well on this data. Okay. Another tool, and this last tool I want to show you today. This is a tool and we entirely built in Lithuania. If you ever dealt with PagerDuty, we're using PagerDuty for alerting. We send our alerts for PagerDuty. PagerDuty takes care of sending those to all individual engineers. But PagerDuty is not great for analyzing alerts. It's not showing history well. It's not you can't see trends and whatsoever. Even search for individual alert. It's if you don't know number, which you always don't because you just know the name or what about this alert was. It's pretty much impossible. So we built an on-call dashboard. We graph all alerts. We have per team or per rotation, as we call it. You can select your rotation. You see the line, who is on call actually, who is secondary on call, the alerts who came, the status of alerts, some details of alerts. You can actually do some actions based on that alert, which integrates with PagerDuty and some other tools we're using. And I would say the most important thing, okay, most important thing the system does, you can actually tag the alerts. You can tag them by the reason why this alert actually triggered and by the action, what was done to mitigate this alert. So now you tag them, you can tag them, maybe some even text-wise explanation. It's good in a few ways. First is like, not all our teams are 24/7. Some teams are 12/7. So that means like 2 rotations. So next guy, and usually in very different time zone, let's say Lithuania, comes in, and he can already see, okay, what alerts came, what was done with those alerts, what reasons were, and actually, or some alerts left for him to solve. Other thing, we can actually start doing some analytics on alerts. We can actually analyze this data and draw some patterns, what's happening with our system, are we going better, worse, what's the reasons of each of those, and apply some engineering power to solve them. Yeah. That's it. I wanted to tell you today. I don't know how we're doing with time. I think we're pretty good. 10 minutes to lunch. So that's nice. I'm able to take any questions if you have some. Okay.
Creating thresholds. I saw like similar pattern and it's stock market analysis. Have you considered applying moving averages and predictions and not doing all this artificial intelligence you're doing? This is great.
Yeah.
Just like
We're doing like, of course, we're using all the functions which are available in Graphite. Just it's not working for us well. We can't predict, like we need like, you can't like do, I know how moving average will look like if you would like to say, I want Thursday 5 p.m. like 1 week ago, 2 weeks ago, 3 weeks ago, compare this and out of this data calculate. And it's a lot more science. Even with moving average, just like simple moving average, it's a lot more science than just to expressing this to engineers. Like simple graphs and simple number of anomaly.
is it possible to use F3 with other data sets that are supported in the
Currently, no. Currently, it's like just works with M3. It's actually with M3 and M3QL both tied together. So and it's not open sourced yet. Probably, I don't know. I'm not familiar with the timeline. Do they plan now open source this?
How about the dashboard, the on-call?
Yes. On call dashboard, I know guys have actually tried to start develop it as open source project, but they diverge from that because they have so many integrations with our internal tools, and it's not easy. But that potentially could be open sourced, and that what we see is missing on the market. That could make sense to so many teams actually around. So we're talking about this. So, but No other questions? Then, yeah. That's it. Thank you. Thank you for listening.